I hope all colleagues are here now because it is 11 now, yeah.
Okay, thank you, Noah.
Are
Rashid,
welcome.
I think we can start.
welcome.
Go ahead,
Okay,
Maja.
thank you. Thank you. As I said, welcome everyone. Since I'm not sure that I have met all of you at our first home training of the three project and the study visit in Slovenia, I will introduce myself firstly. And then my job for today is to present to you some practices. I will not say that they are good, but they are practice examples of project-based active collaborative learning with industry, with the nonprofit sector at our faculty. And I will try to also tell you how they evaluated through, how they evolved through the years and what European and national mechanisms are available and supported us on the way. So my name is Maja Michel. I am the project coordinator for FTPO for the three projects, and I'm also the head of the career center and project office at FTPO. And at the time when we started this project based learning, which was more actively in 2017, I was also the director of the faculty and I was leading the activities of that I will be presenting. And I will be happy to answer any detailed question after this presentation or in Lisbon or via email. We agreed with Dr. Hassan that I will take about 1 hour, including questions, because I will be very happy to hear also about your good practice examples. And together we have about 2 hours for this. So I will start my presentation. First, I will touch shortly the question why we started, of course, with these activities. I think we have talked a lot about this. It is basically also the same reason that we started with the flipped classroom approach. We have been talking a lot about what skills our graduate need, not for the future, what skills they need now. And that these soft, horizontal, transversal skills, anyhow, we name them, are very important for the success of our graduates on their career paths. And these skills, according to OECD, according to the World Economic Forum, according to CEDEFOP, or any research, I would say, are among others, analytical thinking, problem solving, creative thinking, leadership, now also empathy and active learning is becoming more and more important. So you can see from the type of skills, if we touch on the World Economic Forum analysis for top 10 priorities for 2027, you can see that the technology skills are, of course, important, but that cognitive skills and other self-efficacy and other skills are becoming more and more important, including, as I said, very importantly, critical thinking, problem solving, communication, and all the others. I will not talk about theory a lot because I'm not an expert per se in this, and I want to save time more to talk to you about how we did it, what challenges we had, and how we then actually addressed those challenges and moved forward with other projects and activities. But of course, to sum up again, there are many benefits of project-based learning, cooperative active learning, and these are that they develop exactly the skills that I have just presented are so important for our graduates. And also, of course, as we discussed yesterday, um, they give us the opportunity to go up the Bloom taxonomy triangle. So to do with our students what we want to do with them. So not only to give lectures, but to give them the opportunity to apply their knowledge, to even analyze, of course, their knowledge, to evaluate and even create new ideas. So I believe with active collaborative techniques that I will show you today that we did that. So we not only gave them the opportunity, but we made them they had to apply the knowledge that they received before. They had to analyze the challenges, the industry challenges. They needed to work in teams. They needed to evaluate the problem, of course, from all aspects. And they needed to, of course, create their own ideas. And this is the benefits and the theory behind it. Of course, here I will send you this presentation. You have a little bit more details on the benefits of project-based learning, including what I have already told you, but also adding on that I will show you, and this was this is what our evaluation showed, that the students' motivation definitely increased, that we could see their creativity, their curiosity, that they said to us in the evaluations that we did, that they got an in-depth understanding, not only of the challenges and the theory, but also of how they will need to apply the knowledge in a real world, so in a workplace. They also said that, or we saw that they were much more confident when we did it with them the second time or the third time, or the students that actually cooperated in the projects that we did outside the curriculum. They were much more confident in their also presentation skills, communication skills, and these projects gave them not only a sense of purpose, as it says here, but also we have given them an opportunity for connecting with industry partners. And some of them, of course, some of these networks and connections resulted also in students being hired or graduates being hired by the industry. It also, what we talked today with Rudy, it allows for differentiation. So for individualized learning experience and tailored instructions. And of course, it also promotes lifelong learning. Now, at FTPO, as I said, we have started active collaborative learning activities within the curriculum from the beginning, actually, within, for example, the course project management, where the students did not only listen to the theory about project management, but they actually developed, implemented smaller projects, really small projects. So we started with that 15 years ago. We also, of course, we have a very strong center for cooperation with industry, where we cooperate with more than 300 companies from Slovenia and abroad, and give them support also by actually providing service for them. Either this is optimization of their processes, characterization of materials, or any other consultant services. So we already have had a lot of cooperation before, not in the study process, but research and development, which of course resulted also in the fact that some thesis work and seminar work within within our study programs were conducted on challenges from industry, which I'm sure you also have done or are doing now. But then in 2016, with the new strategy of FTPO and the strategic goal that we want to empower our students to be ready for this fast changing society and for the future demands of the labor market, within that, we actually started actively applying for projects and doing activities to work with industry more intensively and within our courses. So I will tell you in detail how we did that and what were the activities that we planned so that we would do it in the right way and reach the impact that we wanted to. And then also outside of the curricula, so outside of obligatory activities of students within the courses, so our bachelor and master course in polymer technology, these are our courses that I'm talking about. We also had project work done with the students as an extracurricular activity. And I will present to you in detail a funding mechanism that Slovenia had and now will have again that actually supports this project-based learning, but not only project-based learning, for example, of our students, so polymer technology students with the company, but actually interdisciplinary projects with at least 3 different faculties, for example, I don't know, industrial design, marketing, and engineering, or healthcare, polymer engineering, and mechanical engineering. Now, Slovenia has a specific funding mechanism that I will present, and you will also get a link that we believe was extremely beneficial of actually pushing us higher education institutions to work with industry on such project and doing it in the right way. So we were very unhappy in 2020 that Slovenia decided not to fund these projects anymore, but we just received the word, and I think this is a very interesting coincidence, yesterday from our ministry that there will be tenders for this type of projects from this autumn on, and we are already generating ideas to apply for this tender. So my presentation today, in the next half an hour, I really want time for your questions, will be about how we started activities of active and collaborative learning within our study programs. So I'm talking about industry project within our technical courses, and then the funded projects, Creative Path to Knowledge. First, I will talk about the funded student projects that I have just told you about. So there was a tender which was published in 2016 already, which is called Creative Path to Knowledge. And our Ministry of Education, Science and Sport provided funds, and these were, I will jump here, the funds of our European Social Fund, and the funding was actually about 11 million euros. And if you will check this website here below, this link, you will see how many projects, I think it was more than 400 different small projects were funded with this 11 million or even more. And I don't know how many thousands of students were involved. So these were really small projects. I'm not talking about 6-figure numbers, but more along 10,000 euros, where all the funds went into paying the mentors, some material costs, and also the students get paid. But I will talk about that a little bit later. So the aim or the main goals of this program, Creative Path to Knowledge, was that students, in addition to their studies, so to their obligations in the study courses, would be motivated to participate in research and development projects with concrete, of course, industry partners or the non-profit sector. So it is not, there were 2 programs. One was for the industry and the other one was for the non-profit sector, meaning municipalities, hospitals, different types of communities, or we say društva, I'm not sure how, institutions, non-profit institutions. And the aim of the program was to develop creative and innovative solutions to challenges in the corporate sector. So the students are supposed to work on a concrete challenge with the industry partner or partners and solve this challenge. And the project group is 4 to 8 students from interdisciplinary programs guided by professors at the higher education institutions and of course from experts from the corporate sector. And the duration of this project was minimum 3 to maximum 5 months. So the students from the start of the project, of course, the goal and the activities and the mentors were defined before this point. But when the project started, we had 3 to 5 months. It depended on what we wrote in the application for them to finish the work promised in the application. So the benefits that the ministry has foreseen for this project was that there would be mutual exchange of knowledge, experiences, and good practices between professors and, of course, experts from the industry sector. And I have to say that this is definitely a benefit that that came out of these projects. Of course, the other benefit is that the aim was to bring creative solutions to the economy, because we found that even though this is extra work for people from industry, but as I said, we have been doing this now for a while, it is not difficult to motivate an industry partner to cooperate. Of course, usually it is easier for the bigger companies who have a little bit more, who have an R&D department and who have at least 100 or 200 employees, have the capacity to cooperate a little bit more. But we also cooperated, as you will see a video, with startup companies who also need. We all know that there is so much our students, with the help of you, the mentors, can provide to the industry sector. There is a lot of creativity, of knowledge, if we do this systematically, and at the end, the company gets a solution. Maybe this is a little bit too optimistic, but they get ideas for the needs, for the problems, for the challenges they have, and maybe they do not have time to work on. So these are ideas that are stuck in a drawer, and the engineer who needs to work on the problems that he has now doesn't have time to do it. For the third benefit or the third aim was to connect students, companies, and faculties, and encourage sharing of good practices. Of course, we all know that we want to cooperate more with industry partners, and in this current time, in this crazy tempo, sometimes just these things don't happen because we don't take the time. And with having such a project, of course, and I have to say, personal experience from FTPO is we also thought about who to contact, because with this, the aim of FTPO was also to show ourselves as a competent partner for an industry partner, which we wanted to work with either within other projects or, of course, within the service provider. So there was a short list of companies that we know we wanted to work with, and we decided who to choose also regarding that. Of course, students get practical knowledge, experience, as well as make connections. I have to say that at least one student per project got a job offer, and or a thesis was then came out of so we came to with the solution to a certain level, and then of course new questions arise, and then there were diploma theses or new projects and so on. I already told this, that companies gain help with problem solving and find, of course, employment candidates. And the faculties, so us, can connect theory with practice and can practically update their study programs and roll out new innovative approach teaching. As you will see later on with our development project that stemmed out of these creative path activities, it also resulted in change of course curricula It resulted in adding guest lectures from industry to our study processes, the guest lectures that we got to know within such projects. So as I told you, this is a fund that was made up by our national government. And this was the period 2014, 2020, but actually this project started only in 2016. And the tender conditions, and I don't know if there is a representative from your educational ministry. I can also, if this sounds something that maybe the ministry would like to get to know a little bit more in detail, I can even set up a meeting with our representatives at our ministry who have just developed the new program, because of course we were not satisfied with all the conditions of reporting and the tender. So we now have already at least 5 years experience in doing these projects. And now, as I said, they have just opened a new tender. So if anyone would like to, I can try to set up a meeting with our ministry to explain the other part, so the funding part of this project. But anyhow, the tender conditions were that the challenge, of course, needs to be described and needs to come from the industry or the nonprofit sector. And very importantly, and I found this very beneficial for us as the higher education institutions and for the students, of course, as well, the students and mentors need to come from different fields of study. We all know that the complex problems that the industry now has usually involve a team not only of experts from physics or mechanical engineering, but that you need to evaluate such challenges and find solutions also always or in terms of business models and economics, that you need to then think about also marketing opportunities, so and dissemination and communication, that when you talk about development of a product, you need experts in design, you need experts in construction of parts. And in our case, now, since we were the ones applying for these projects, of course, we provided experts in materials, in processing, in construction, in simulation, and so on. I'm talking about the students. And also the mentors need to be from different universities. And it is of crucial importance that there is really a motivation from the industry partner or the nonprofit partner, so that they need to know before we started the project that this will take some time, that they need to be involved, and they need to cooperate at least at the beginning and at the midterm evaluations and at the end. Otherwise, this is not a cooperation with industry. This is just a project that we came up with at the universities. So 3 to 5 months, I'm sorry, here is a mistake, 4 to 8 students, but we always had more than 6 students. And what is also interesting when we talk about motivation of students to do something outside of the study courses, the ministry decided to fund the work of students. So this means that when we applied for projects, the mentor got his hours paid, the university got the material costs and the travel costs covered, but the students got quite a nice fee per hour to work. I'm at the beginning, I have to say I was quite critical about this, because I thought, okay, this should be something they should be motivated to do. I am very interested to see the new tender, whether they will do the same. But the fact was that this did raise the motivation of students participating, so it was easier to get students who would participate. And of course, so they were paid via student. I don't know if you have this. Students can work, and so there is special legislation on how this works. So they work part-time as a student, so they are not employed, and this is how it worked. Now, FTPO, I'm actually not sure if I forgot any projects that we did, but these are the projects that I remembered that we did. They were very, very different. And even now, when we are discussing already, as I said yesterday, came the news that we will apply in September. We will try to do it in a balanced way, but we are focused only on one field of study, polymer technology. So my wish is that we will apply something with the non-profit sector within the career center. So here there was, and it's not written here, there was a project which we applied for, and I forgot to put it on, with the nonprofit sector, where our goal was to motivate primary students and secondary students to do more research activities with mentors that we provided. So we had different workshops, and the students, of course, had to create different activities on how to do that. So they were in the lead. They decided on how they will promote this. Then we had also a project with the nonprofit sector, with the hospital in Slovenj Gradec, and with students from mechanical engineering, computer science, or something like that, electrotechnic. Of course, our students and our mentors were here to as experts in material and product design and processing, because the end product was a dosing system, a new dosing system for medications for hospitals. And as you can see here, this is quite a broad challenge. So they needed to, of course, we guided them a little bit, but actually almost all the projects start with analysis of what already exists. So what already exists and what are the needs, and then the hospital told them why they are not satisfied with the system that they have now, or with the product that they have now. And then, of course, it is idea generation about what this could look like. And then you might imagine how this looks like, because then we will have students from the field of electrotechnics and the design student, for example, saying, "What this I have this idea," and then the mechanical engineering and design students and polymer students say, "But this will not be possible." And then the economic student says, "Yes, but we need to evaluate the costs. Nah, this is much more expensive than the product that is already on it." These are the type of projects and activities that we do at the beginning. Then we also opted for more research projects. For example, we knew that we have competences stemming from our master thesis on new materials for 3D printing. So it's SLR, it's VAT polymerization. I hope I'm saying this right. So it's the photopolymer 3D printing. And we had already competences because one of our students built a master thesis on this. And we knew that there is a company in Slovenia, Helios, who has the monomers already in house, because they produce paints and these sort of things. And we thought that this would be an interesting new product line for them, because we actually wanted to push this to the market, and we didn't have the resources or the equipment or the, I would say, time to do this on our own, or to push the student to go in. And the student, which was at that point already our researcher, didn't want to start a company doing this. And we knew that this was a business opportunity. So we contacted Helios, this big paint producer, and we said, maybe we have this knowledge. Of course, we could also sell it to them, but this we didn't know how to. So we actually gave all of our knowledge for free. But the students worked on a new material for 3D printing with the knowledge that we had already, with the expert from Helios, and with also some other chemists from the chemical faculty, and also, of course, from the economics faculty, because again, the market analysis was made on what was already on the market, where are the prices, and which product would actually make sense, where are the niches in the market, and what is the economics behind it. And of course, then we had the technology, so mechanical engineer, because the whole process need to be set up. And so this was another project that we did more with experts on materials. So we did not focus so much on the technology part. Then the other project actually also started from our previous work with the company Magneti, who actually produce magnets with injection molding technology. And we knew that there was a need and an idea that you could print magnets with 3D printing technology. And we, again, had competences at FTPO to do a filament for 3D printing. And so we were looking with the company Magneti on how to do this. They didn't want to fund the project because it was a little bit maybe not 100% sure that it will work. This was not a work for a thesis because it was more practical, and we needed mentors again from the mechanical engineering part. And so at the end, I have to say that this was again a very successful project. So if I go back to Helios, after this project of new material for 3D printing, we had a master thesis on this, and then the Helios actually put the product on the market. So they are now selling the material that we developed within a project within the Creative Path project. And printing of plastomagnets, it was the same thing. We actually had after this, so this was the first experimental part, and they did the filaments. Actually, the filament was 95% of rare earth particles and only 5% of matrix from polymers, and it was printable. Of course, all the challenges were not solved, but I have to say again, 4 years later, the company Magneti is selling the 3D print and has a line. They didn't have anything to do with producing filaments. Now they bought a whole line for 3D filament production, and they put this on the market. And we have been cooperating actively with both Helios and Magneti. And also, I think the reason was this successful student project. Then, sorry. Oh. So sorry. I have to go back. Then the next project was again completely different. Beef jerky was actually a startup company producing, I don't know if you know the product, this is something Americans usually eat. It's dried beef in a stick. It's supposed to be healthy as a snack. This was someone who has won on this national competition as a startup producing this. But then the idea was that usually you eat this in a car, and they had an idea of a product, a beef jerky holder for the car that they wanted our students to produce. So it was something that was a little bit further from actual industry needs, but we thought it was an interesting project. And we called our Academy of Arts and got a great mentor in industrial design, because of course here our competences of our engineers are in materials and in production methods and not in industrial design. So we had two designers from University of Maribor and from University of Ljubljana. We had a marketing guy who also in parallel was developing a marketing campaign. And we had our students, we had a mechanical engineer also, and we had actually someone from a multimedia course who was with us from the beginning and actually video taped all of the activities and produced a nice video at the end that I will show you a little bit later on. So at the end, I will show you this video. You will see all the activities where we have the brainstorming at the beginning with the company. The company representatives were, of course, at this, I think it was 2 full-day workshops discussing, first presenting the problem with the students, then also discussing opportunities. Then our students did, of course, a whole analysis of different types of cars and places where this holder could be put, because every car has a different front panel, and then materials. And we were talking actually when we applied the project about a cup, then it was not a cup, and then the designer went in, and then a whole. So you will see the video of how I think you will see how the students are motivated to work on and what we produced as a final example. And then again, the last project that you see here, solving the problem of adhesion and the unpleasant smell of organic waste bin, is again a little bit more of a research. So we also, as I said, try to apply for projects, and we will do the same this year to attract different types of students, because some students will be very happy to work on the beef jerky holder, where they have to communicate a lot with the designers. It is more a marketing and a business and entrepreneurial thing. And the other students are more research oriented, and they will not want to be at a design thinking workshop for 2 days and having to speak, even though this is one of the aims of the project. But they, for example, will be working on this last problem, thinking about new materials from which the organic waste bin, which a company Casa produces, will be produced to solve the fact that the waste, the organic waste, sticks to the wall. So they designed and developed and tested at the end a new material with Teflon, which provided this adhesion properties. And again, then microcapsulation was involved, and we had students from microbiology and from chemical faculty, which put in some microcapsules that were used already in paints and in I think in diapers as well, to solve the unpleasant smell of the organic waste, because this bin is used in a kitchen, small bin, and you can produce for biological waste, so for food waste. And of course, the unpleasant smell is a problem that the company had, that the customers that bought the bin told them to. So why I'm talking in such detail about these topics is so that you can see we are a polymer technology faculty. But as you see, the different projects that we do outside of the curricular again, and how we connect, how we wanted to connect with very different higher education institutions with, as I said, Academy of Arts, so University of Arts, then microbiology, then mechanical engineering, electrical engineering, marketing, economics. Now we had students of all of this, and we at the faculty here applied for this project as the lead partner. Of course, our students were involved, because when you apply and connect with some teacher from the industrial design, they also invite you back. So then our students were invited to their projects. Here I'm explaining only the projects that we started and coordinated and implemented. And now, again, I will try to. I hope it works. I'm sorry, I will do it in a different way. I want to show you this, so I will go on our YouTube channel and show you the video from there. Just give me half a minute. You will probably not hear the music, but it's not important. So this is the video that the student produced. These are the representatives from the company presenting their needs and issues. Then we had a project leader, which was actually the project leader here was our professor for project management. And she led these workshops where the idea generations and problem definition was made. And this was made as a whole day event. It was obligatory for all students and also for the company. This is the product. And then afterwards, of course, the students got also the competencies of not only how to do idea generation, but how to successfully and efficiently run the project, as you have seen, to do in progress done, how to lead the teams. We had specific project leaders, and in the project, everyone had their own obligations. This was, I think, a very good, and they connected as students. They are still friends. They still cooperate with each other. This was the design student running, designing the solution at the end. Of course, the solutions were very different. As I said, we started with the cup, and at the end, the solution was this back holder, so that the back was put in. And as I said, they had to do a whole analysis of different types of cars and the most often cars used in Slovenia. And at the end, the product was, so the material definition had to be made, the technology, the price of a product, the tool for producing the plastic part. It was a soft part and a hard part. And this prototype was done with 3D printing. And as I said, one of the students that cooperated, I will send you this link. One of the students that cooperated was also from multimedia, which is always a good thing, I would say, because at the end, then we also, of course, want to promote this type of projects. And we got a very nice video, as you could see. Going back to my slides. Okay. So I put in the link of we can look at it together, where you actually have a little bit more about, this is the webpage of our ministry. I will also put this in the chat, where you can see how they funded this. There is not a lot of actually details regarding, we cannot even see the tender. I can send you the tender after it's published and translated to English if you want. But here there is also a list, for example, of projects that University of Ljubljana did. Of course, again, I think
eu tô numa videoconferência. Se eles olharem onde é que eu tô, vai dar
Can I
ruim.
ask someone
Mas aqui é branco.
to mute the microphone? I hear someone. I think I hear Isabella.
It's Isabella here.
So here it says that only in one opening of the tender, there was 100 projects and 720 students that cooperated with 252 pedagogic mentors. And see the numbers now, and the ministry spent 10 million euros, which sometimes EU spends for 2 projects. So again, I send you this link. Now I would propose that I move on with the second part, so how we do it in the curriculum. Is that okay, or do you want me to answer any questions now in between? I can move on. Rashid?
Yep.
Okay. Hassan? Okay.
I think you can. It doesn't seem there is any question here, so you can carry on.
Okay. Then, so this is what we did with the help of some funding. We could, of course, you can imagine, do this also without funding, but it will be a little bit more difficult to motivate the mentors and the students and the companies. However, why we started doing this within the courses? We found out the students that participated in this outside curricular project activities were the motivated students, if you know what I mean. So they were already the students that had above average competences that we wanted them to have. and they were already motivated. So what we decided at the faculty at that point, now with the strategic goal in mind to empower every student, at least try to empower every student with these competences, and give them the opportunity to see what a real life project in industry works like, and to push them to do presentations, to work in teams, and to get these competences. In order to do that, we need to have this within the curriculum. What this means is that we do it within the courses. And so this was the development goal that we set for ourselves in 2018. And the goal was development and pilot implementation of the concept for implementing active and collaborative teaching and learning in technical study programs, so within the curriculum. And again, we actually promised this to our funding agency, the ministry. We said this will be our development goal for 2018, 2020. And we told them we will do this in this way. So we did, again, first the literature review and good practice example analysis. So how do the other faculties do it? What does the research literature say is needed? What are the challenges? How we needed to set up to have the maximum impact? We also try to use other funding that we have to do interviews. So we somehow got into an OECD workshop. I went and had interviews, and people showed me, for example, like I would go to you and you would present for 2 days. I went to universities mostly in Austria and Germany, and told them, please, I am here on Erasmus study visit as a head of career center. I want to learn how you do it. And they explained it to me. And we also, of course, looked within Slovenia how other faculties that are similar to us do it. Then we prepared the concept, how we will do it at FTPO. We, of course, did not forget that the key person that needs to have the motivation to start these activities, because it is extra work, are our professors. And so we trained our professors, but mostly we didn't train them, because professors know how to do it if they have coordination, but they need to have the motivation and they need to see the good practice examples. So we took them to excursions, to this to the LIT factory in Linz, for example, and we had lectures from abroad, telling them their experiences. And then we actually found out that we will need new study literature for students. So this was one of the activities planned. We will need to change the course syllabus for different subjects, because at the end it will not be a written exam, for example, but the exam will be a presentation of students in front of the industry partner. Then pilot implementation, of course, a few pilot implementations to check whether the concept that we thought of was the right one, analysis of results, dissemination of results, and then next steps, new projects. I will be presenting one of the first projects that we had within the activity. So first, as I said, the literature, the concept, and also discussions with our chairs and with our professors, explaining, and then looking for the first pilot professors that we will do it. And then, of course, looking for the first industry topic project. And the first industry project topic was with the company Collector. Why? Collector is a very big company, a very successful company in the other part of Slovenia, which we wanted to work with. They didn't work with us before because we were at that point 10 years old. We are a very new faculty, and they cooperated with bigger universities. But we had some activities with their R&D department, with their laboratories and so on. And we just went to them and told them, we want our students to become the right engineers of the future. We want to implement collaborative, active learning, project-based learning within our courses. We want to solve one of your challenges. Please discuss with us the topics, the possible topics, the problems that you have that could be evaluated and implemented within our study courses. And we are actually doing the same thing now, right now. We had a meeting 2 days ago with the same. There is another company, Silico, which is a market leader in producing elastomers for the automotive industry, especially seals for batteries for electric cars, and really a successful company of 1,000 workers in Slovenia. And we did the same thing as we did in 2018. We had a meeting with the leaders, meaning the manager of the company, the R&D head, the technology head, and we told them, I think our students can be beneficial. We propose that we collaborate with them like this. You can also publish thesis. We will also help you get EU funding, but let's have an open discussion. Please activate your engineers to give us the challenges that are stuck in a drawer or that you don't have time to look at, or your concrete needs. And we did the same with Collector. They gave us a list of at least 10 topics, and we looked at them, and then we gave them feedback. We told them, we think this is more for a PhD study. We think this one is something that we cannot do because we don't have the competences. We should go to another faculty. This one is a little bit too elaborate for a student project, but this one and this one could be done within this course and these two courses, and we want to talk about how to do it. And this is where we are now with Silico, and this is what we did at the Collector. So the topic that we have chosen was what to do with the Duromeric waste, because they produce also not only thermoplast products, but also thermoset products. And you might know that thermosets are not easy to recycle because like thermoplasts, now you cannot actually recycle them. You can use them as fillers, or you can burn them, or anyhow, but this is a big expense for Collector and a big waste for the environment. So the challenge that our students got was what to do with this waste. Can they use it within any other product within Collector, because Collector has a big assortment of products. So here is actually I tried to write how we did it. So meeting with the company to define the problem. This was after the problem was already defined. And then at the FTPO, okay, this is the problem. What can we do? What needs to start first? So we will do a research analysis of possible composites with thermoset waste. So looking through, this was actually a research literature review, what was already done on this topic. Then on the other hand, in a different course, what products Collector has and what needs it has, in which product we could use a material with this waste. And then, of course, afterwards, and this is also important, if you want to do project-based learning, connecting 3 different courses, in our case, it was polymer engineering, it was project management, and it was polymer processing. You need to consider the fact, are these the same students? Are these courses starting in the first semester? Is the course that should be at the beginning starting only in the second semester? And these were a lot of problems that we have. So at the end, we chose the courses which start in parallel. So the polymer engineering, the group of students developing a material and the group of students processing started at the same time, and this was a big problem for us. So there was a big time issue because they had to do the literature review really fast and then present the possible materials development issues, and then they needed to develop the material. And so the processing group had to wait until the material was developed to start optimizing the processes and so on. So these are the challenges that we had with the Collector issue. But at the beginning, and we did 5 such projects afterwards with industry. the important thing is then not only how we do the concept and the right topic, but also how we present the topic to the students. So we always push, and this is obligatory for the company, for them to present the challenge. And before that, for them to present company. So in the collector case, we had, after all the meetings with our professors and me as a coordinator, the students, we rented a bus and the students went to collector and they had a full day excursion learning about all the technologies and all the products and of course also the challenge at hand. So they went to the company and this was also at the end evaluated very positively, and this is what we do all the time. And then of course we have a mentor, a project leader at the company who is with our mentors and with the students from the beginning to the end, because they then needed to, at our end, to define when the collector will send the material, what particle size this waste will have, what type of material. We needed to get a lot of information from the company in order for our team to develop the new material. And then they worked within one semester, and then they continued in another semester in product design. And in this one semester, two professors had to align the activities. And I have to say, at the end, the first pilot implementation showed that this is not so easy to do. The professors or the mentors, the assistants, two very motivated assistants, Silvo Bolka and Jane Slapnik, were very angry with me because they had a lot of extra work to do. And because they said, especially the polymer engineering part, I cannot take all the hours to push them to work on practical problems because they need to listen to the theory first. You're taking time away from me. And so the students, okay, will get the soft skills, but the specific competences and the outcomes, the learning outcomes of my program, at the end, the exams will have not been written, so they got lower grades on the theoretical exams because I didn't have a lot of time. So we had a lot of challenges in this first implementation. But at the end, the company was very satisfied. The students did a great job. Of course, we also had to tutor them. This is where the Career Center comes in, on how to present then their work to the industry partner, how to do the presentations. They learned a lot in this because they did not know, they prepared the presentation with a lot of really detailed theoretical parts about the material, which the company will not understand maybe. So how to do the right presentation for the company at the end was also something that we needed to teach them. Then besides this, I will start sharing the video because 1 hour is up. This is another case, and I will talk when you can look at it. I just need to mute. This is another case that we had. So after this collector case, we did 5 more industry projects in 8 courses. And this was another project with Plasticas Casa, where they worked on a biocomposite, which had to be food approved for a specific product that they had. And I will also send you this video. Actually, the company paid for this video because it was a big marketing for them as well, and of course for us as well. We will subtitle this video in English so that you will hear by tomorrow. We will send it to you. I didn't have time to do it, I'm sorry. And you will hear the comments from students, what they learned, how they why we did this. So this was a video about why we are doing such project collaboration. This is the R&D head of the company's Casa. She was filmed in our laboratories, and she is telling us why Casa is doing this project and why they benefited And this is the first presentation of the problem. So the excursion of our students to SCASA, they went several times to the company because they actually produced the prototypes at their equipment. We just produced the material. This is in our laboratory. It's one of the students explaining why what they learned and how he is saying how happy he was that they worked on real industry problems, and they did the characterization at the end, and they had big problems with migration tests because it needs to be food approved. So you will get an idea of how this is made. And I think this is, again, if you need to convince your bosses, this is a big plus also for university to present ourselves to the industry partner and the community as doing these innovative teaching methods. Okay, the evaluation results, as I said, we had pilot implementation in 8 courses. We had to change the course syllabuses. There was a lot of challenges, as I said, and because of these challenges were also opportunities to improve. So what we found out is we only had, it seems small, but it's not a small problem. We only had lecture rooms with fixed chairs. And for project learning, this is not good. So what we did is we actually developed, and I will show you another video, we convinced the company SCASA to donate to us equipment for a new room, which was then our project learning room for students where they could do the group learning. And this was our old laboratory. We moved to the big one that you saw when you were here. And the designer from SCASA, this is again the head of innovation and development, telling them why they gave us the money to equip this room. But they actually gave us, I don't know, it was not a lot, it was 3,000 euros, but they did all of this. So they designed the room, and now this is a student room which they use very often, not only for project-based learning, but for studying, they have their own coffee machine. And so these small parts are also important. If you do project-based learning, you need to have a room which is which is not a typical lecture room. So the other thing, the other thing, and then I will finish, is that we decided, as I said, the professor said, I will not do it anymore. We need to organize this in a different way. We had so much time pressure to produce all the presentations, and then the second professor said, yeah, I got the information very late. I didn't have enough time to do the optimization of the processing. And therefore we did polyflip. We decided as a team that the flipped classroom approach method, so doing the theory beforehand so that we have time to do the project work in the contact hours, is one of the solutions. And we had no idea what flipped classroom approach was. So we decided to come up with a project for Erasmus, and we found the best mentor in the world, Lut, to teach us in the next 3 years. And as I said, the aim was to do this so that we overcome the challenges which we evaluated in the project work. We also, here is our course syllabus. After the flipped classroom approach, we found out that it would be very beneficial if we had, and I don't know if you have this in your universities, that you have a specific course which is actually aimed at doing the project work. So now we designed a new course. Let me just find it. It's called Systematic Development of Injection Molded Parts. I will send you the link to this course. This is actually a new elective course on the master level. It is here in English on the right side, where actually the students get the knowledge of systematic part development, but the course is organized, if you see here, in the way that we have workshops with a group of minimum 5 students, And we actually build a company, not build a company, but we have again an industry problem. And one of the students is the project leader, one is the head of tool designs, or one is the material expert. And then they actually use the state gauge process of systematic product development. And the whole 6 months, they do product development and or optimization of products for a company. So we had, as you see, two ways of overcoming the challenges that project-based learning with industry within the curriculum has. And one was to use the flipped classroom approach methods to have more time with the contact hours to go to evaluation, analysis, and creation of new knowledge. And the second part is to create a separate course where we could do this, where there is no theory, but the aim of the course is to work on a specific. We didn't do it at the bachelor course because we cannot find, even though I would like to, we cannot find hours to do it because there are other courses which need to be taught. But this is an elective course, which, by the way, this is now the second year. The students didn't choose. So we didn't implement it yet because the students didn't choose it. So to sum up my presentation, this is how we do it, or this is what we did in the past years when it comes to industry cooperation. Besides this, of course, we have, as I said, a lot of excursions, and you have it too, and guest lectures. But this systematic, I will say, implementation of industry projects within the curriculum is one of the toughest things that we try to do. We still are trying to do it outside and within the curriculum. I personally believe, and our Dean Blaž can tell you again, and he told you already a few examples of how he does it within his courses. We believe